Good day, everyone, and welcome to another problem solving session with Special Maths Academy. We'll be going to the next number theory problem in the series. We're discussing the just concluded Nigerian Mathematics Olympiad for the senior category 2020, the first round. So, number 42, find the smallest positive integer k such that 2 raised to the power 61 plus k is divisible by 255. So I have 32, 64, 223, 234, and 252. So to do this, let's first of all break down 255 to its prime factorization. And that is one very important tool in number theory. So this is equal to 3 times 5 times 17. Okay? Now, 2 raised to the power 61 plus k. For 255 to divide 2 raised to the power 61 plus k, each of these primes must divide it. So we solve some modular congruences. Mod 3 raised to the power 61 plus k congruent to 0 mod 5 and just to 3 raised to the power 61 plus k congruent to 0 mod 17. So we need to solve this system of linear modular congruences. Okay, so 2 raised to the power 61, this can be expressed as 2 raised to the power 4 raised to the power 15 times 2 plus k congruent to 0 mod 17. Okay, here it can be expressed as 2 raised to the power 4, and soon you'll see why I'm expressing it in this way. 2 raised to the power 4 raised to the power 15 times 2 plus k congruent to 0 mod 3. Here it can be expressed as before, 2 raised to the power 4 raised to the power 15 times 2 plus k congruent to 0 mod 5. Okay, so 2 raised to the power 4 is 16. Times 2 plus k congruent to 0 mod 17. 2 raised to the power 4 here is 16 again here. And there are a lot of ways of solving this manipulating these modular equations. It just depends on the one that's most convenient for you, the one that has to do with the least computation. Okay, and then here again we have 16 raised to the power 15 times 2 plus k congruent to 0 mod 5. Okay, so 2 raised to the power, so 16 is congruent to negative 1 mod 17, and once we have 1, one is much more easier to handle. Okay, times 2 plus k congruent to 0 mod 17. 16 is congruent to 1 mod 3, so this is 1 to the power of 15 times 2 plus k congruent to 0 mod 3. 16 here is congruent to 1 mod 5, that's when you remove 15 from 16. Okay, so this is 1 raised to the power 15 times 2 plus k congruent to 0 mod 5. And here I'll just skip. This is negative 1, so this is k is congruent to 2 mod 17. Okay, so this is a positive 1, so this k is congruent to negative 2 mod 3. And here we have 2 plus k, so just put k is congruent to negative 2 mod 5. Okay, so here we can k is congruent to -2 mod 3, so this is same as k congruent to 1 mod 3, and here this is same as k congruent to 3 when you add 5 mod 5. Okay, so let me put them somewhere here. So k congruent to 2 mod 17, k congruent to 3 mod 5, and k congruent to 1 mod 3. Okay, so let me quickly erase this. Okay, okay, so a quick way of erasing this is just to select it and erase. Okay, so now from k congruent to 2 mod 17, what does that imply? It means k is of the form, rather k is equal to 17a plus 2, some integer a. Okay, so then k congruent to 3 mod 5, so we put that for k. So we have 17a plus 2 congruent to 3 mod 5. So what does this imply? 17a, this 17 is congruent to 2 mod 5, so we can put 2a there. And then the 2 goes to the other side and we have 1. Okay, and so we have we can add 5 to this side so that we can divide by 2, because we can divide by 2 because 2 is congruent, 2 is relatively prime to 5, so we can divide by 2, so we don't have any problems dividing. So this is the same thing as 6 mod 5, and then we have a is congruent to 3 mod 5. Okay, so we can say a is equal to some 5b plus 3. Okay, so we can replace that. So you have k is equal to 17 into 5b plus 3 plus 2. Okay, now we have k is congruent to 1 mod 3, so we can put this for k, 17 into 5b plus 3 plus 2 congruent to 1 mod 3. Okay, so we can see that 17 is congruent to 2 mod 3, so we can quickly replace that, and this is 2, 5 is congruent to 2 mod 3, and 3 is congruent to 0 mod 3, so this is just this, and then we have 2 goes to the other side, so this is congruent to -1 mod 3, and we can add 9 to this side so that we can divide by 4. So our 4b is congruent to 9 plus -1, and that is 8. We're adding 9 because 9 is a multiple of 3. Okay, and we can divide by 4 because 4 is relatively prime to 3. So our b is congruent to 2 mod 3. Okay, so it means we can say b is equal to some 3c plus 2, and everything here we're dealing with are integers. Okay, so it means I can put it somewhere here. K is equal to some 17 into some 5 into some 3c plus 2 plus 3 plus 2. So for integer c, this is what k satisfies. And we can begin to open up the bracket. So I have k is equal to 17 into, so this would be 15 c plus 10 plus 3 plus 2, and this is k is equal to 17 times 15, that is 255 c, and this is 17 times 10, this is 170. 17 times 3, that's 51, and plus 2. Okay, so what do we have? K is equal to 255C plus, so 170 plus 51 plus 2, that is 223. So we're looking for the smallest positive integer, so that occurs when C is 0. And so we have this. Okay, so that'll be all for this video. See you guys in the next video. Till then, keep on solving maths. Don't forget to share, like, comment, and subscribe. Goodbye, guys.